Welcome everyone. Today we will give you a crash course on computer networks. Have you ever wondered how does the process of sending the message look like? To imagine it, let's first of all consider a simple connection of two computers, one of which has a connection to printer. In order to print something, first PC have to have a simple copper cable connection with another PC. Then it can send any message. This network is called peer-to-peer. Now, let's think of bigger networks as WAN, LAN and WLAN. In this case, if we use a wireless access point, we will get wireless local area network with one server and intermediate and end device. End device PCs are interconnected with the help of intermediate device as routers, switches, and hubs. Now, let's create a local area network, which means the same as wireless local area network, but without any wireless connection. Now, our LAN and WLAN can connect each other to make a WAN, which means wide area network. Finally, the collection of WANs create an internet consisting of WLANs, LANs and WANs, so internet means interconnection of networks. Now, imagine our WLAN is a university network and our LAN is our home. If university provides server only within the university, it will be intranet. Vice versa, if the university can provide a server outside the building but only for its students and labor, it's gonna be extranet. The connection models in the networks are called topologies. Here are some topologies you have know about. The first is special with its simplicity and it's not protected from loss of connection, bus topology. The second is more persistent to connection loss as long as it's sticky, ring. The next is even more protected as it structures a connected graph, mesh. And the last one is a star shape. All of them can be the parts of a mixed topology.
Now you can imagine which kinds of devices and connections are necessary to make a simple network. And let's consider what happens when a server sends us messages. Every data in the network walks through standardized layers, which are represented by two models. First is TCP/IP with layers of application, transport, internet, and network access. Second one is OSI model, which consists of three extra levels. Now application layer consists of application, presentation and session layers, and network access is replaced by data link and physics layers. All the layers have their own units of data. Today I'll explain you the OSI model. The bottom layer, physical layer. In this layer we use technologies as Ethernet, Wi-Fi, Bluetooth, infrared port to work with different types of signals, as radio waves, light pulses, and electric signals. For example, we have a host, server, router, and interconnected them using different cable types, so physical layer encodes and transmits data signals over different media, whether it's wave, light, or electricity. Data link layer consists of LLC, which connects to local devices, MAC, which tracks access to the physical layer, and Ethernet technology. In this layer, frame is created. It consists of SFD, the start of the frame delimiter, destination MAC address, and source MAC addresses, which are given by MAC. MAC address refers to the physical address of the device. Next is the data itself and frame check sequence, which checks for errors. Bits are packed into frames. Next is Internet layer, which is strongly associated with routing, mapping addresses, finding paths. Uses routing protocols like Open Shortest Path first and protocols as ICMP, IP. Unit of data link here is a packet. Layer's important headers are the length indicator, needed protocols, and destination and source IP addresses, which are provided by IP. IP address is the logical address of the device. It means it varies depending on the network it's connected to. We can get IP address by sending DNS request using the domain of the host. Finally, the actual data section is the last one here. Packet is created. Transport layer. Here it used two important protocols, TCP and UDP. TCP is more reliable, but UDP is faster. TCP connects first and sends, but UDP sends and waits for answer. One more difference is in their method of sending the data. As you can see here, data blocks sent by TCP will be received the way they were sent. In UDP, it will be received in order it reached the destination. First of all, headers of network layer consist of port numbers. It's needed to know which application is used for data. For example, for DNS request, we need a port number 53. Next is sequence number for data retrieval order and acknowledgement number for tracking session. This is the way segment is created. Finally, session layer works with the connection integrity and sessions. Presentation layer works with the format of the data. An application layer shows the data with the right application on the user interface. Now let me tell a little about these applications. For mail we use SMTP POP3 IMAP. For web files we use HTTP HTTPS. To send files FTP SFTP SCP. For video calls we use RTP, and for messengers XMPP. All of them have their own unique port numbers. So we have covered all layers of OSI model and saw what data overcomes to come to your device. All steps I have described refers to encapsulation-decapsulation processes. We encapsulate from application layer to physical and in opposite direction decapsulate. Finally, I want to tell you shortly about security measures against threat attacks. Use firewalls to be safe from site modifications, use access control to control users' actions, use encryption to privatize important data, use VPN to create secure tunnels with confidential data, use update and patch to fix weak points, use IPS to track suspicious actions. Thank you for your attention.